let's have a look at B. Prove that the product of two consecutive, one after the other, odd numbers is an odd number. All right, so we're required to prove that the product, so we're multiplying, of two consecutive odd numbers is odd. So I thought it wouldn't like that word. Let our first number be, well, to get an odd number, if we multiply any number times 2 and add 1, we're going to get an odd number. And k is an integer, but it's an odd integer. Okay, and our second number, well, if they're consecutive, if I said 1, 3, 5, 3 and 5 are consecutive odd numbers. So to get the next one, if I add 3 instead of 1 to my 2k, I'm going to get my next odd number. Okay. Now, our product of those two is going to be 2k plus 1 times 2k plus 3. And we can expand that. So we've got 4k squared plus 6k plus 2k plus 3. And that's going to be 4k squared plus 8k plus 3. Now notice that these two terms here, I could factorize out a 2 from them. So I've got 2 times 2k squared plus 4k plus 3. And there's something interesting that I can say about this factorized piece over here. Okay, so I can say, well, but 2k squared plus 4k is an integer, okay, because if I multiply, add or subtract with integers, I get another integer. And I can then make that whole thing equal, for instance, n. So that means I have got 2n plus 3. And we've already set up at the top here that 2k plus 3, where k is an integer, is odd. So I can then say, well, 2n plus 3 must also be odd, which is odd. So therefore, product of two consecutive odds is odd.